Hello everyone. In this video lecture, I'm explaining the conversion of FSM to regular expression. In this conversion, I'm going to use the state elimination method. We have one more method where you can apply Clean's theorem method to convert FSM to regular expression. That will be discussing in the next video. Let us see how to convert a regular expression. Before that, we need to let me give you an introduction regarding this. Suppose if the FSM containing a single character, okay, suppose if the FSM containing single character, then we will allow entire regular expression as label, something like this. That is, I have this, there is a single character, maybe A, then this is your regular expression. Since it is this FSM itself contains a single character, what is the regular expression for this is A. And similarly, for a given input FSM M, we will construct machine M dash, we will construct machine M dash such that M and M dash are equivalent, and M dash has only two states, start state and single accepting state. Suppose if you have given a bigger FSM, in that case what you have to do is finally in your converted FSM, that is M dash, how to generate M dash, finally in your M dash you should have a start state and then the accepting state. Only these two can contain, and there is a transition saying the regular expression whose label will be a regular expression of entire machine. Okay, so you have to convert, given input FSM is M, then you have to construct machine M dash like this. Okay, and whose states are only accepting state and start state, that is only two states. Okay, and whose transition will be the regular expression expressing the whole M dash, that is expressing your M also, because M and M dash are equivalent. Let us consider the example. If I have an example something like this, okay, and now finally what you have to do, this is your M, this is going to show a regular expression, for language of M. Now you have to give a regular expression for this. Okay, how to get or obtain a regular expression for the above finite automata using state elimination method. These are the two ways normally it can be asked. Now how do I finally get? I should get something like this. You had a start state and then the accepting state. There can be only two states can be present in the M dash, and transition need to be labeled with the entire M. That is, what does this M is going to give? That is, it is going to give A, it's a loop, so B star and then A. It is A B star A. So your transition has to be A B star A. So regular expression is A B star A. So this is how final M dash should be. Now let's see the algorithm to create a regular expression for FSM. First of all, remove any states from a given FSM M that are unreachable from the start state. Remove any states from the given FSM M that are unreachable from the start state. So if you have a input like this, if you have a machine input FSM like this, and you should check, this is the start state, this is the accepting state. Now you should check, is there any state that are unreachable from the start state? That means you can also check like this. You have to check, is there any state that don't have a directed path from start state? So Q2 has a directed path, Q3 has a directed path. You can observe here to here, here to here. But whereas Q4 don't have. If you don't have that, for a particular state, if don't is not going to connect from Q1, then you should remove that state as well as the transitions from it, as well as the transition from it. Next, if M has second step, if M has no accepting state, then halt and return the simple regular expression null. So if something like this, if you have a machine contains only this kind of thing, then what you should do? You should return a null. Third step says if the start state of M is a part of a loop, then create a new start state S and connects to M's start state via an epsilon transition. This is a new state S will have no transitions into it. Let us consider an example. In this example, you can see that this is the start state. How do I identify the start state? Start state should have an arrow like this, okay, and which shouldn't be coming from anywhere else. Only for the start state will have something like arrow on this, okay, and this is a start state. And now what you have to go check? You have to check is whether it is part of a loop. How do you observe that? How do you check that it is part of a loop or not? You have to check whether any transition coming into it. You can see here that there is a transition coming into it. There is a transition coming into it. That means it is forming a loop, that is going and then coming. So it is kind of a loop. Here if you see this, using this also makes a loop. How? This way, and then this way. So that means there is a state, there is it is this is a start state who is part of a loop. Now what you have to do? Now you have to create a new start state, and which will not have any no transitions into it. And what you have to do? You have to create a new start state, and then let me show you, okay, something like this. That is, you have to create one new start state. So earlier let us this named as 1, 2 and 3. Let me create a new start state called 4, and then connect the earlier start state with an epsilon. So now you can check 4 has no transition coming into it. Okay, so this is about the third step. These are the steps you have to check one after the other. Now, if regarding accepting state, if there is more than one accepting state of M, or if there is just one but there are any transitions out of it, create a new accepting state and connect each of M's accepting state to it via an epsilon transition. Remember, in the final result, that is in the conversion of FSM to regular expression, finally what you want, you need to have one start state and one accepting state, and the transition is going to give you a expression of a regular expression. Okay, so that is why you have to, if there are more than one accepting state, or if there is any accepting state but there is a transition going out of it, then you have to create a new accepting state and connect the existing accepting state to it via an epsilon transition, and convert the old accepting state as non-accepting state. That are the things you are going to do. So here this is the accepting state, isn't it? This is the accepting state, this is the accept. There are two accepting states, right? And there are transitions going out of it. If so, what you're going to do? You have to create one new start state and connect the earlier accepting state with epsilon. Fifth point, at this point, if M has only one state, then that state is both start state and the accepting state, and M has no transitions. So language of M equal to epsilon. If M has only one state and that state is both start state and accepting state, then the language of machine will be epsilon. So the regular expression is just an epsilon you have to return. This is the case. The regular expression you're going to return is epsilon. Sixth one, until only the start state and the accepted state remain, what you have to do? You have to eliminate some state rip of m's. You have to eliminate some state that is named it as rip of m. And okay, any state you can remove, that you can, for that moment you can rename it as rip, and any state except the start state or accepting state may be chosen. So you can't remove in the rip while choosing a state for a rip in the sense you're going to remove it, okay, that particular state. So that's why while choosing a state for rip, you can't choose start state and accepting state. Okay, then after that, after selecting the state rep, you have to remove rep from m and modify the transitions among the remaining states, because after you are removing the middle state in, so the whatever the transitions that are that are possible with that you have to adjust with the remaining states. The labels on the rewritten transitions may be any regular expression. So you have to modify the transitions among the remaining states so that M accepts the same string. So even after removing the rip, you should not alter the meaning of the earlier ones. So that's why you have to modify in a such a manner. So the whatever modify the transitions label will be in the format of regular expression. And once removing this steps, these three steps, 6.1, 6.2, 6. These three steps you have to repeat until you get only start state and accepting state and the transitions. Transitions will be the transition of the whole machine. Finally, return the regular expression that labels the one remaining transition from the start state to the accepting state. Let us consider an example. So this is an example. Show a regular expression for language of M. Obtain the regular expression for the above finite automata using state elimination method. These are the possible questions for the conversion of FSM to regular expression. Now, what's the first step? According to the first step, you can observe that according to the first step, you have to check for any unreachable state from it. From if this is a start state, 2 is reachable and 3 is reachable. That is done. The next step is, what is the next step? Next step is regarding the start state. What is that? You can see here, regarding the start state, there are transitions coming into it. That means it's part of the loop, isn't it? So you have to create a new start state. Create a new states, and also I'm going to create a new accepting states as there are you can observe. I'll go back and show you the earlier. See, as there are two accepting state, so what I have to do, I have to even create a new start state, as well as why create a new start state, because transitions coming into it. So you have to create a new start and join the earlier starts with the epsilon, and create a new accepting state, join the earlier accepting state to that using epsilon transitions. You can observe here epsilon transitions. Next, ripping. After this ripping, which state to remove? So I will remove this particular portion, this state. So for time being, for the first time, rip is 3. Remove state 3, rip is 3. If I remove 3, I will get something like A star B. Let's see the how. you can see that if I remove this, the meaning whatever this transition is going to give is, it should be same. How? You just check what are the transitions coming into it. Based on that you can decide. So it is only towards one direction it is going. So A star and then B. You can write it as A star and then B. This is what we got after removing 3. Which is the next state to be removed? Let's check that. Remove state 2. So after removing state 2, what are the possibilities? So you can see that the transitions coming into it 2 are this one, isn't it? And that is taking 1 here and then this, isn't it? 1 here, that will give you AB. You can see here this will give you AB, and one more you have, that is A star B. So AB union A star, because it's a parallel line. One is this and one is this, also can go in this manner. So A star B. After that one more, this 1 to 5 is connected as A. Okay, so 1 to 2 is connected in this manner, AB union A star B, and 1 to 5 is connected A epsilon is A. Okay, so you can see here after removing state 2 what you have got. Next you have to remove 1. How to remove 1 now? So after removing 1, what are the changes that are going to happen in the FSM? So if I remove this one, if I remove this one thing is the connection will be from 4 to 5. That will be the final regular expression you are going to get. Now you can look at that, between 1 to 5 there is a parallel line, isn't it? So there is a two parallel lines. That means you can directly write something like this. That is 1, 4, 4, and then epsilon, then 1. So AB union AAA star B, AB union AAB star B, and then this portion can be written as A union epsilon, A union epsilon. Okay, this is how you can write it. After that, it is easy for you people to can write the final regular expression. What should be the final regular expression? You should finally have only start state and one start state and one accepting state, 4 and 5. Okay, now you can look at this portion AB union A star B, that let me take it as X. AB union AB, let me take it as X equal to AB union A star B. Now what is this going to give you now? Write here AB epsilon X A union epsilon, isn't it? Epsilon X A union epsilon. Anything if you concatenating with concatenate any object, if you concatenate with epsilon, you're going to get that object itself. So that's why epsilon X is X A union epsilon. What is X? Is it X? This is, if I consider this as X, this has to be an X star, not X. Kindly correct it. So this, if this is X, then what's the loop of X? That is X star. So you get X star A union. What is X now? Let us write the final expression. AB union A star B whole star A union epsilon. A union epsilon. Finally, after removing the state, you are going to get AB union A star B whole star A union epsilon. This is the final answer. You have to write the regular expression. Give the regular expression as AB union A star B whole star A union epsilon. So this is about FSM to regular expression conversion using state elimination method.